Welcome to today's Explainer lecture. There's this massive myth we really need to bust right out of the gate. We all kind of grew up thinking of space as this static, perfectly still painting hanging over our heads. But today, we're looking at some incredibly groundbreaking recent astronomical data, and we're going to prove that that idea, it is totally false.
So, before we even get started, what if I told you that deep space is actually moving right in front of our eyes? Seriously! It is not a still painting. It's a wildly dynamic, constantly moving environment. We're talking evolving nebulae, newborn stars, and massive cosmic explosions that are literally still rippling outward. And the best part? Today, for the very first time in human history, we finally have the tech to sit back, watch it happen, and prove it to you.
All right, here is our syllabus for today. First up, we'll look at cosmic motion. Second, we're diving into the infrared revolution. Third, we'll talk about telescope synergy, and we will wrap it all up with the human perspective.
Let's jump right into Module 1, Cosmic Motion. Here, we're establishing Hubble's historical baseline.
Okay, the absolutely crucial thing to grasp here is our tools. The Hubble Space Telescope has been our workhorse, giving us decades of baseline data using visible and ultraviolet light. It basically shows us the surfaces, right? The glowing stars, stuff our own eyes might see if they were superpowered. But then we have the James Webb Space Telescope. Think of Webb as our cosmic X-ray machine. It uses infrared light to peer straight through those dense, totally opaque dust clouds to reveal the hidden heat and massive structures buried deep inside.
And this brings us to a really brilliant case study, the Crab Nebula. Get this, way back in the year 1054, Chinese astronomers recorded a star exploding, and it was so intensely bright they could see it in broad daylight. Fast forward to 1999, Hubble snaps its first full, detailed image of the wreckage. Then, in 2026, researchers compared the new images to those old ones and realized the filaments of this dead star are still racing outward at 5.5 million kilometers per hour. We are literally watching an explosion expand in 3D, mapped across nearly 1,000 years of human history. How wild is that?
But the Crab Nebula holds a really bizarre secret. Most supernova remnants just kind of coast outward, pushed by that initial explosion shockwave. Not this one. Dead center of the Crab sits a pulsar. That's a city-sized neutron star left behind by the blast. It has this ridiculously intense magnetic field generating a glowing blue core, and it is actually driving the expansion of the entire nebula from the inside out.
Now take a look at the Trifid Nebula. Back in 1997, Hubble photographed this super dense dust cloud, affectionately nicknamed the Cosmic Sea Lemon. Well, when astronomers looked again in 2026, they saw that a jet of plasma, fired from a baby star hidden inside that dust, had visibly pushed forward. We actually clocked the speed of a newborn star's plasma jet in just a few decades. It's an incredible reminder that these majestic, towering dust clouds, they're completely temporary. Millions of years from now, harsh ultraviolet radiation is going to dismantle that entire cloud, leaving just the naked stars behind.
All right, let's move into Module 2, the infrared revolution. We're going to see how we peer right through the cosmic dust.
To really appreciate this revolution, we have to talk about our medium. You see, visible light just bounces right off dust. That's why nebulae look like thick, solid clouds to Hubble. But infrared light, it slips right through. By detecting wavelengths of thermal radiation, which is essentially just heat, Webb can see the fiery glow of objects that are completely buried deep inside these dark cocoons. Webb turned this infrared vision toward the Orion A molecular cloud and captured practically every single stage of star formation all in one neighborhood. It is literally like looking at a stellar school photo. You've got the newborns completely swaddled in dust that only infrared can spot. You've got the rowdy teenagers violently firing off jets and creating these glowing shockwaves. And then you have the oldest stars, sitting there having cleared away their dusty cocoons entirely, just shining out in the open.
Webb also showed us a truly fascinating structure officially named Dracula's Chavito. It's this massive 400 billion mile wide planet-forming disk that we're viewing directly edge-on, but infrared shows us it is wildly lopsided. You have these wispy, delicate filaments of gas raining down on the top and a sharp, clean edge on the bottom. There was enough raw material in there to build 10 to 30 Jupiters. It absolutely proves that planet nurseries are these chaotic, messy places, constantly being thrown off balance by nearby forces or fresh material raining in.
And we don't just use this on deep space. We can apply this same technique closer to home.
Switching between Hubble and Webb on Saturn is literally like peeling the planet layer by layer. Hubble gives us those soft, familiar bands we all know. But Webb's infrared, it makes the rings blaze white because of glowing water ice, and it reveals this strange, completely unexplained gray-green haze at the poles. It just goes to show how different wavelengths uncover entirely different depths of an atmosphere.
Let's zoom way back out, over to the Messier 77 galaxy. For centuries, it just looked like a perfectly normal galaxy. But Webb's infrared gaze cut straight through the core and revealed a blazing center that outshines billions of stars. Spoiler alert, it's not a star cluster. It's a supermassive black hole. Webb even found this glowing bar structure, acting like a conveyor belt, feeding gas straight into the center. We are literally watching the thermal glow of gas heating up as it spirals in. Essentially, the black hole's last meal.
Then there's the Westerlund 2 cluster. It's incredibly crowded and constantly blasted by radiation. Hubble couldn't see through it, but Webb's infrared vision did. It successfully spotted failed stars, things we call brown dwarfs, which are objects only about 10 times the mass of Jupiter, just hiding among 3,000 blazing hot neighbors. By finding these tiny objects in planetary systems caught mid-construction in such a violently harsh environment, Webb really forces us to ask, well, if planets can form here, where can't they?
Okay, moving on to Module 3, Telescope Synergy. Let's look at what happens when we combine these multi-wavelength powers. This is where we see true synergy in action, specifically with the pinwheel galaxy, Messier 101. By teaming up, Hubble's visible light maps out the blazing young giants and the older yellow stars, while Webb's infrared layers in the glowing orange-brown dust clouds threading right between them. Combining that data gives us a complete flat blueprint of an entire trillion-star system. We can see exactly how this enormous 170,000 light-year spiral organized itself.
We see this incredible layering technique again with the Cat's Eye Nebula, which is basically a preview of how stars exactly like our own sun eventually die. Hubble zooms in to read the inner fossil record, these tight concentric rings of gas shed in pulses by the dying star. But when we layer in data from the Euclid telescope, which is built for super wide sky surveys, it reveals an enormous ancient halo of glowing fragments way out beyond the center. Layering different telescope data lets us read a dying star's final chapters in perfect chronological order.
Now, sometimes we catch a star right in the exact middle of this dying process. A pre-planetary nebula is an incredibly rare, super brief cosmic stage. It happens right after a dying star sheds its dusty layers, but just before its core gets hot enough to actually make that gas glow. Hubble captured this exact fleeting moment in the Egg Nebula. The hidden central star is basically acting like a giant searchlight, its beams bouncing off the thick dust cocoon before the whole system fully ignites.
Fast forward to a slightly later stage of stellar death, and you get the Red Spider Nebula. This one features massive, 3 light-year-long bubbles of gas driven by a central white dwarf star. In visible light, that star looks really faint and blue, but Webb's infrared upgrade found that star glowing a fierce red, mysteriously shrouded in hot dust. That intense heat signature is a massive clue. It strongly hints at an unseen secret partner, a companion star actively helping to sculpt those giant bubbles from the inside.
Finally, we arrive at Module 4, the human perspective. Let's talk about our own place in this cosmic loop. I want you to think about this cosmic recycling loop we see in the NGC 5134 galaxy. Gas clouds collapse to ignite brand new stars. Massive stars explode, tearing giant holes in the dust, while gentle stars swell up and calmly shed their outer layers. All that material, it just returns right back to the galaxy to build the very next generation. This proves a pretty stunning reality. Literally every single atom in your body went through this exact loop before Earth even existed. We are, quite literally, built from this recycled stardust. And while our machines are out there capturing distant galaxies, we definitely shouldn't forget the human explorers. Contrast all those machine-captured nebulae with this amazing event from April 2026. 4 human beings aboard the Orion spacecraft photographed a total solar eclipse from the far side of the moon. Their eclipse lasted 54 minutes, and in their photo, you can actually see Earth shine, our home planet's glow, brushing the lunar surface. It's a beautiful reminder that exploration, at its very core, is a deeply human endeavor. As this quote from our source material so beautifully states, the universe is stranger and richer than we expected. Layering these incredible technologies, Hubble's visible baseline and Webb's infrared deep dives, literally peels back the universe layer by layer to show us exactly how much richer it truly is. All we have to do is just keep looking. So I want to leave you with this final thought to end today's Explainer lecture. Considering everything we've uncovered today, from the fierce plasma jets of newborn stars to the dusty, fading breath of dying ones, if every single atom in our bodies was forged in this exact cosmic loop, how does seeing the universe, peeled back layer by layer, change your understanding of our own origins? And really, what is our next step in this grand, dynamic cosmic loop? Thank you so much for joining me today, and I will see you next time.